This is my ROV project. I'm building an underwater drone, and I'm making it out of PVC tubing. And I have these motors here. They're DC brushed motors, so that's what I'm going to use. I'm hoping that these little blue ones are going to work for me. I did buy these. These are both clockwise and counterclockwise, so they kind of counter the torque of each motor. So there's going to be two in the back to drive it this way and back and forth, and then I'm going to have two pointing up like this, and they will make it submerge and go down or come back up. And also, because I'm going to be able to control the speed of these motors, I have DC speed controllers. So they're DC motor speed controllers. And so I'll actually be able to make the drone tilt down, nose down. So it'll pitch down, or it'll pitch up, or level. So I should be able to, with the speed controllers, also the ones that are in the back, I'll be able to go forward and go back, but I'll also be able to turn. And being that there's two motors, I can make one go forward and the other in reverse. I can turn on a dime, or I can do sweeping turns. So I'll have pretty much complete control. The only thing it won't do is it won't bank like an airplane, but there's really no need for it to do that. They do make ROVs, little ROVs that will do that, but I don't see no reason for that. So I got these brushed DC motors. They're rated at 7.4 volts, I believe, but they'll run all the way up to like 30 volts, I think. But basically, they're 12-volt motors. But I think they're designed to run at about 7.4, which will be good because I'm going to have, because I'm going to be running, probably I'm going to try 150 feet of line. So I have this underwater camera that's it's for fishing, actually. And so you can see the fish. It makes it easier to catch fish if you can see that there's fish down there. And it's got a 150-foot line on the camera. So it also has a monitor. So here's the screen, color monitor. And here's the camera. So this is going to go on the ROV, and this is what I'm going to use to steer the ROV and see what I'm doing. So this is going to be real time underwater. It's a closed circuit television technology, so it's older technology. It's not 4K or anything like that. It's a little bit better than the standard of old televisions, so it's color, and it's good enough. It looks good enough. I've tested it that it'll be fine for what I need it to do. And this also has a recorder, so I can record. But what I'm planning on doing is, when I get this all done, is hook this to my flat screen monitor inside my boat, so I'll be able to drive the drone from inside my boat. And the main reason I'm building this is because I want to be able to inspect the bottom of my boat without going in the water. And I'm going to try to set this up to where I can actually clean the bottom of my boat with it. We'll see how that works out. I don't know how good that's going to work out, but I'm definitely going to give it a try. I'll probably have to do some modifications. That's one of the reasons I'm using PVC tubing, is that some of the parts, the main parts, the floats, the top floats on the top of the ROV, they have to have floats on them for buoyancy. So the ROV needs to float just on the surface. And so you can, in case something happens, I lose power or whatever, it'll slowly float back up to the surface. And so the float part is the big tubes here on the top. They're going to be all glued together, so they'll be watertight. The rest of the tubes, I'm not going to glue them. So I may through bolt them with bolts to hold them together. And the reason for that is that I want to be able to change things if I need to. So if I need to redesign this ROV, I can do that easily without having to start over from scratch. If I glued everything together, then that's it, it's glued, and then I'm screwed. So if I need to change it. So at any rate, so this is the camera. There's 150 feet of line here, cable for the camera. And also what I'm going to do is I'm going to put my GoPro camera on the ROV as well, so I can film 4K. I can't see through this while it's underwater. It's Wi-Fi. Though I have an idea where I might be able to make it work, but that'll be a future project. But so it'll have two cameras. It'll have the fishing camera, and probably above it I'll have the GoPro camera. So that's the plan. And we'll see how it works out. So I'm hoping the weight of these cameras and the motors are going to kind of work as ballast, so I don't have to add more weight to the bottom of it. I still might have to add weight, but that's not a problem, because the bottom tube going across the bottom, I'll be able to take it apart and I can put weight inside there. So I don't know what I'd use for weight yet. I'm thinking maybe some long all-thread stainless steel, like a bolt. But it doesn't like have a head on it. It's just all thread, and so it's a threaded rod. And I might get a couple of those stainless steel and put them in for ballast if I need to have ballast. So that's the plan there. So right now I'm going to start by just putting the PVC tubing together and see how my design looks. I'm pretty excited about the design I came up with. So we'll see how it works out. I've checked out several different DIY ROVs videos on YouTube, and most of them have just a lot of PVC tube, and they're like a big box, and they don't look very hydrodynamic, which is like aerodynamic. I designed this to go through the water easily, so with less drag. So than a lot of the ones that I saw. So they all worked really good though, the ones that I seen that looked like there'd be a lot of drag. They still moved really quick and fast, but this will be a little bit, hopefully more efficient. So now I did get some other motors, but I decided against using them because these kind of motors, even though they're like 12 volt, and I got both clockwise and counterclockwise, and they're really cool. And a lot of people use these for underwater drone projects. But the problem with these is you have to have a speed controller, and basically, so you're going to have electronic circuitry on the drone, plus you're going to have a battery on the drone. And I don't want to do that. I don't want to have another battery. I have to charge it up before I can use the drone. This design here that I'm going with, because I'm using these brushed DC motors, there's not going to be any electronics on the drone at all except for the cameras and the motors. And the motors will be driven by my big lithium iron phosphate battery that I built for my boat. So I got this huge battery bank in here in my boat, and if everything works out, it's going to be totally run by the big battery bank. So no recharging batteries or anything. The only batteries I'll need to recharge will be for the GoPro camera, and that's it. Well, also there's this camera too has a battery, and it'll also have to be charged. So I might be able to work around that, and also be able to hook this in. I got to look at the voltage on here and see what it is, but I can deal with it. It says it's 12 volts. Yeah, so the cool part is I'll be able to bypass this battery. So everything's going to run. I'll be able to make it so everything is going to run on my big battery bank in the boat. And so I won't have to recharge this. So the only thing that'll have to be recharged is the GoPro. And so I'll be able to get really good high quality 4K underwater video with this. And so this is just for filming, and this is just for driving the drone. So we'll see how this works. And I'm going to start putting this together now. So what I'm going to do now is I'm going to start building the floats, because they're going to have to be glued. And I think I'm going to get a piece of plywood out here. I need something flat to work with so I can make sure these things are glued straight. Once you put the glue on, you got to work really fast because the glue dries real quick. And I want everything to look real straight. I don't want anything real crooked. So I'm going to get a piece of plywood and bring it out here. Okay, so, and then I got these caps that are going to go on the end, and I want to make sure it's got printing on here. Dura is the brand, and I want the lettering and everything to be straight. It bugs me if stuff is a little crooked. And I've talked about that in previous videos, that if I build something, I like everything to be perfectly straight. I don't want anything crooked. If somebody else builds it and it's crooked, it doesn't bother me. But if I build it, it's crooked, it drives me nuts. So I'm going to have to cut some stuff with the Dremel tool, some of the pipe, because my cutter here, I got this cutter. And it's for cutting pipe. These things are the way to go when you want to cut PVC pipe. You don't want to use a saw, because you're going to have all these little particles, dust particles of plastic going everywhere. And this is real quick, real accurate. It cuts real straight and real easy. And I've done a lot of PVC work in the past, and I'd always use a saw. And it was like, why didn't I ever get one of these? I don't know. But yeah, I got one now. So I'm going to have to get my vacuum out, because I'm going to be using a Dremel and it's going to be throwing dust, and I want to get all the dust in the vacuum cleaner and not anywhere else. One thing you want to do is wear eye protection whenever you're using any power tools. That actually worked out pretty good. That looks, yeah, look at that. Looks good. Okay, so I'm going to need to make 6 of these. So what this is going to do is this going to go in here. And I don't want to push these all the way in, because even though I don't glue them, they're going to be hard to pull apart. But that's going to glue this, and then it'll be all the way flush. So you won't even see this part. I'm going to have to work real fast. And I can't screw it up. So here we go. Man, I'm slopping it. Just a little bit on the edge. Okay, here we go. There, like that. Now twist it and make sure it's straight. Damn! Okay, I think that's good. Okay. Yeah, it looks straight. Whew, that was wasn't easy. that one went all the way on. Twist it. Yeah, there we go. All right. So they don't fit tight anyway. So I think that's as far as they're going to go anyway. So, oh, that looks good. That's straight. That's straight. So there you go. There's one of the floats. It's heavier than hell. I don't know how well it's going to float. It looks pretty good, and it's not like having smaller pieces in between. It's all the same size. So it's very hydrodynamic, moving through the water. So I'm hoping this is this thing's going to float. Okay, so there's the floats. My cutter. Now these things are awesome. I mean, watch how easy this is. Let me get this on here. So just ratchets closed. Okay, it cuts through here like butter. Ooh, the tube's collapsing. What the hell? That's weird. There it goes. Wow, the whole tube was collapsing. I was surprised. Oh, you know what? Is this schedule 40? This don't look like, this is like a schedule 20. It's schedule 20. Oh, that's okay. That's just gonna make it lighter. This whole top part's sealed, but water can get in and get into this if it's upside down. But this will never float upside down. It's always gonna be floating right side up. It's gonna tilt like this, but it won't tilt enough so water can get in here. I made drill holes in the lower pieces so water can fill the tubes in the bottom, and that'll take away some of the buoyancy. And I need ballast, so I need heavier weight on the bottom of this thing so it'll float right. So, okay, so we're getting there now. Got to make another one. Not too tight. So some here, some here. I might make it shorter. Like that. So that looks a little wide. Like that. So just get it straight. Okay, there it is. And there it is. So, yeah, I like this design. So it's, like I said, very hydrodynamic. We'll see what happens. Now, see, the bottom's going to flood, but this is all airtight, so this should have air in it. So hopefully it'll float. Let's see what happens. Don't sink. I don't want to lose it. Okay, here we go. Not bad. So yeah, I designed it in my head and made it work. Okay. Okay, there it is. Wow, that went together pretty quick. Yeah, I totally designed this in my head. I didn't write anything down. I was going to make it a little different originally, but it would have had like smaller diameter and bigger diameter and smaller diameter and bigger diameter pieces, because I was going to hook all these together. Then I was going to put foam for floats, and I come up with the idea using all these couplers here, the T's and the plugs for floats, so they're all uniform, the same diameter, all the whole length. Same thing with the bottom part here. It's all the same diameter, and these sides here are pretty much the same diameter. For some reason, these T's are bigger in diameter than these, but it's close enough. It's weird on the top. These top ones, the bottom ones are, it's kind of strange how that worked out. And the only part that's skinnier is this way, but that's okay, because this is going to be moving through the water. These pipes are going to be sideways moving through the water, so I wanted them to be smaller diameter for less drag. So this is going to have very low drag compared to a lot of the ones I've seen on YouTube that people are building and designing. This one is very sleek, hydrodynamic. I'll be able to mount stuff in here. I can put a platform in here if I want, across here. I still got to put the 2 motors in the back, and then 2 motors pointing up like this, but they're reversible, so it'll push the ROV underwater, and then those 2 motors that are facing this way, I can control both of them separately, so I can tilt this down, nose down, which is good because you want to look at the bottom. If I'm looking at the seabed, I want the cameras pointing down at an angle, and eventually I may come up with a manipulator arm, so I can treasure hunt, pick stuff up off the bottom, or if I drop something overboard, if the water's not deeper than 150 feet, I'll be able to go down with this and retrieve it. Even if I lose an anchor, I could go down with a line with a hook and hook it on, and then maybe pull it back out. Yeah. So, but mainly I'm going to use this for inspecting the bottom of my boat, and I'll be, hopefully when I get this all done, I'll be able to drive this from inside the boat using my big flat screen television. So that'll be really cool, and it'll have a depth of over 100, close to 150 feet. So that's really cool. And it floats good, it's stable, and as long as the motor weight and the camera weight doesn't overdo the buoyancy here. So it was floating right now. Water was leaking in at this joint, so I may have to glue these T's in right here at the top. The bottom part is going to be flooded anyway. It doesn't need to be watertight, and also it's floating. It was right now empty with nothing on it. It was floating about halfway along the float here. So half the float was submerged, the other half was above. Now, when I put the extra weight on, it'll float probably just at the surface. So the water will come up close to almost to over the top of this, as long as it doesn't sink. The other problem is the cable's going to weigh something, so I'm going to have floats on the cable, at least a little ways behind here, to keep the cable from dragging it down. I'm going to use a Cat 6 cable to control the motors, and Cat 6 has enough conductors to do that. But if I start putting like a manipulator arm, I'm going to have to probably add extra wiring for that, because I don't know if I'm going to have enough connectors. I'll have to figure it out. It might be plenty. The Cat 6 might work for everything. It's going to be interesting if I can make these motors spin at 150 feet with 12 volts with a Cat 6 wire. I've seen people, I don't know how many feet they were doing, but they were making this work with like a Cat 5 or Cat 6 wire. That looked like maybe 100 feet. Normally, if you have 12 volts and you run it through a wire, once you go 100 feet, you're not going to have 12 volts out the other end of that wire. It's going to be more like 6. But these motors are designed to run at, I think, 7.4 volts. So we'll see. I don't know if they're going to be powerful enough, but we'll see if it's going to work. I may have to go with bigger motors, which I can do that. I got those bilge pump motors. Those are big, and so they're more powerful. But will the wire be able to supply enough power for them? I don't know. I'll have to see. But I didn't want to. The other way to do it was to make sure that they would run is I'd use heavier gauge wire, like speaker wire, like 14 gauge or something like that. And that would probably work pretty good. But then I'd have to have a speaker wire for each motor. So that'd be 4 speaker wires, and that's going to be a bigger bundle, and it'll make a bigger spool when it's all rolled up, because I have to, the wire is going to be rolled up on a spool. And it's also going to be more weight in the water. So I don't know. I may have to go shorter than 150 feet. I may have to go like to 100 feet. I don't really want to go under 100 feet. I could if I had to. I don't really, to inspect the bottom of the boat and do everything to the boat. I think, yeah, 100 feet would be good. Give me a little extra. Anything shorter than that would probably be a little too short. But at any rate, so there it is. And so if you found this video to be helpful or entertaining, please like and subscribe.